All right, so let's keep going here. So we're on worksheet, I think it's 12.2 on the back side. So this one now we're trying to figure out what? The diameter. Okay, so this piece right here is the radius. So if we can figure out what that is and then double it, then that will give us the diameter. And a couple of things that we should remember from circles and tangents. One is that a tangent line to a circle always makes a right angle with the radius, so you know you've got a right angle there. And then the other thing that you learned at some point, or should have, is that if you draw two different tangents from the same point, then the lengths of those lines are the same. So if that's 22 centimeters, then that's also 22 centimeters. So I'm trying to find this radius right there, which is adjacent to the 65-degree angle. I know the 22 centimeter side, which is opposite. So I'm going to go tangent of 65 degrees equals the opposite side over the adjacent side. And then since my variable is on the bottom, to solve this, I need to go 22 divided by the tangent of 65 degrees. So that is a calculated problem again. So 22 divided by tangent of 65 tells me that my radius is that, but they want the diameter. So before I do any rounding, I'm going to multiply that by 2, which gives me 20. What do they want this to? Nearest tenth of a unit. So that's going to be 20.5 centimeters. All right, then this next one, we are trying to figure out what this angle is right here. So what I'm going to do is I'm going to make a right triangle out of this, what a surprise, and then use that right triangle to figure out what half of that angle is, and then double it to find the whole angle. So this angle right here, which I will call x. If I want to figure out what that is, I know the opposite side here is 5. I know the hypotenuse is 13. So opposite and hypotenuse is sine. So the sine of x is the opposite side, which is 5 divided by 13. So that means to find out what that angle is, I have to do the inverse sine of 5 divided by 13. And so the inverse sine of 5 divided by 13 is 22 point blah, 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 blah. But again, I figured that out by making this right triangle here, and to do that I had to cut this angle in half. And so to find out what the entire angle is, we need to multiply that by 2, which is going to be about 45.2 degrees for that angle right there. Okay, and then for this one we're going to find this angle beta. We did a problem kind of like this before. In order to figure this angle out right here, I need to use obviously this right triangle that they've drawn in there for us. I know that this side right here is going to be 14 inches, but I don't know what this side is. But I'm going to figure it out, because if I know that this is 24 inches, then this is also 24 inches. And if this is 10 inches, then this is 10 inches. And so that will let me use the Pythagorean Theorem to figure out what that thing is right there, because that's also a right angle. So 10 squared plus 24 squared equals that hypotenuse squared. So 100 plus 24 squared is 576 is equal to the hypotenuse squared. So if I want to figure out what the hypotenuse is, I need to take the square root of those two things added together. And the square root of 676 is 26. So that means this side right here is 26 inches long. So now I can figure out what beta is. Since I know the opposite side and I know the adjacent side, I'm going to use tangent. So the tangent of beta is the opposite side, which is 14, divided by the adjacent side, which we figured out is 26. So to get the angle, I have to go inverse tangent of 14 divided by 26. So second tangent, 14 divided by 26 that angle is going to be 28.3-ish degrees. All right, so let's keep going. All right, now I got some word problems here, so we're going to have to draw some pictures. So number 10 says, a ladder 7 meters long stands on level ground and makes a 73-degree angle with the ground as it rests against the wall. So let's make a little picture here off to the side. So here's my wall, and then here is my ladder. And it says that the angle that it makes to the ground is 73 degrees. And it also says the ladder is 7 meters long. And then we know, of course, that this is going to be a right angle. So the question is, how far from the wall is the base of the ladder? So I'm trying to find that distance right there. That is the adjacent side to that 73-degree angle. I know the hypotenuse of that little right triangle, and so I'm going to say that the cosine of 73 degrees equals the adjacent side, which is x, divided by the hypotenuse, which is 7, which means that the distance it is from the wall is 7 times the cosine of 73 degrees. And so you can ask the calculator what that is. 7 cosine 73 comes out to be 2 meters. They want it to the nearest tenth, so that was 2.0 meters about. Okay, next one, number 11. To see the top of a building 1,000 feet away, you look up 24 degrees from the horizontal. What is the height of the building? So this is basically the same drawing as we just did. We have the ground, we have the building, and we know we are 1,000 feet away from the base of that building. And when we look up, our eyes make a 24-degree angle with the ground, and we're trying to figure out what the height of the building is over here. So since we're trying to find the height, which is the opposite side, and we know we're 1,000 feet from the base of the building, which would be the adjacent side, we're going to use tangent. So the tangent of 24 degrees equals the opposite side, which is what we're trying to find, divided by the adjacent side, which is 1,000. So since the variable is on top, I'm going to multiply both sides by 1,000. And so my answer is going to be 1,000 times the tangent of 24 degrees, which is 445.2, what's our units, feet. All right, and then number 12, a guy wire is anchored 12 feet from the base of a pole. So this is the same picture all over again. Here's the pole. Here is the guy wire. It is anchored to the ground, 12 feet from the base of the pole. And the wire makes a 58-degree angle with the ground. So how long is the wire? So now we know the adjacent side to this 58-degree angle, and we're trying to find the hypotenuse. So we are going to use cosine. So the cosine of 58 degrees is the adjacent side, which is 12, divided by the hypotenuse, which is W. And so now, since the variable is on the bottom, that means to find out what W is, I have to go 12 divided by the cosine of 58 degrees. And when I do that, 12 divided by cosine of 58 is 22.6 feet from the ground. Okay, so that is the end of that worksheet, the lesson 12.1 and 12.2. So will you please pass those forward and then get out the next one, 12.3 and 12.4. And I do not believe that we have time to finish this whole one. Maybe we'll get lucky. I don't think so, though. We'll see what we can do. All right, so this now we're trying to find the area, and this is where we're using that formula that I mentioned before, 1/2 AB sine of C. I thought that's what we were doing on the last worksheet, but looks like we didn't. Anyway, so to find this area, this is good because this angle is in between those two sides, so we can use this formula directly. So the area of that triangle is going to be 1/2 of 21 times 15 times the sine of 17 degrees. So that is just a calculator problem. 0.5 times 21 times 15 times the sine of 17 degrees, and that comes out to be 46, what are we in, square centimeters, okay? All right, same deal here, but remember that the angle needs to be in between the two sides, and the 70 is not in between the two sides that we know. But we do know that this is an isosceles triangle, so we have to sort of remember some of the stuff we learned before. Since it's isosceles, those two base angles are congruent. 70 and 70 adds up to 140, which leaves 40 degrees for that angle right there. And so now we can use the formula by saying that the area is going to be 1/2 times 8.7 times 8.7 times the sine of 40 degrees. And so again, we are on a calculator, so we're going to go 1/2 times 8.7, basically squared, times the sine of 40. And when we do that, we get 24, rounding to the nearest square unit, so 24 square meters for that. So the trick there was kind of doing some math to figure out the stuff that we needed. Okay, now we need to figure out the area of this trapezoid. I'm sure that you all remember that the area of the trapezoid is 1/2 base 1 plus base 2 times the height. And we know what base 1 is, we know what base 2 is, but we do not know what the height is. But we luckily can use some trig to figure it out, because I have a little right triangle right there. This 55-degree angle in the corner, the height would be the side opposite that. And we know the hypotenuse is 5, so that's going to be the sine of 55 degrees equals the opposite side, h, over the hypotenuse, which is 5. So the height is going to equal 5 times the sine of 55 degrees, which if I do that, comes out to be, I'm going to try not to round as much as I can, so I'm going to go 4.09576. And then now I can just take that and plug it into the formula right here. So I have to add the bases together first. So 14 plus 8 is 22. Half of 22 is 11. So if I take the answer that I just got times 11, that tells me my area is about 45 square feet. For that guy right there. All right, what other fun do we have going here? All right, so this is where we were using the law of sines. So they're going to start us out with an easy one. So remember that the law of sines says the sine of an angle over the side that's opposite from that angle. So 51 divided by 17 equals the sine of any other angle in the triangle, 40, divided by the side that's opposite from them, or m. So now I just need to simply cross multiply and divide. So that's going to be 17 sine of 40, and then divide by what's left over, which is the sine of 51. And that tells me that m is 14.06, and I want the nearest centimeter, so I'm going to go 14 centimeters right there. Okay, so that should have been a pretty easy one. For the next one, I'm going to do the same thing, I guess. I'm going to go the sine of the 32-degree angle divided by the side that's opposite it, p, equals the sine of the 22-degree angle divided by the sine that's opposite of it, which is 12. So same deal, cross multiply and divide. So 12 sine 32 divided by sine 22. P is going to come out to be, to the nearest centimeter, this is going to be 17 centimeters for that one. All right, and then Q, or number 6, I mean, is only a little bit tricky. I'm going to go the sine of 76 divided by the side that's opposite of that equals, and if I want to find Q, I need to know the angle that's across from it, and I don't. But I know that all of the angles in that triangle add up to 180 degrees. So if I subtract 67 and 76 from 180 degrees, this angle right here comes out to be 37 degrees. So now I can write sine of 76 over 21 equals sine of 37 over q. Same thing as before, cross multiply and divide. So I'm going to go 21 sine 37 divided by the sine of 76. And q comes out to be 13 centimeters. All right, next one. Now we're looking for the missing angle. So I'm going to do the same thing. I'm going to say the sine of this angle divided by 29, the one side across from it. So sine of 81 divided by 29 equals, since I know this 16, I'm going to start out by finding angle C first. So that equals the sine of C divided by 16. So just like before, I'm going to cross multiply. So I'm going to go 16 times the sine of 81. And I'm going to divide that by the other side, which is 29, and I get some crazy decimal number. And so the reason I get this crazy decimal number is not because I did something wrong. It's not because that's what the answer is. It's because that's the sine of the angle that I'm looking for. So in order to find the angle, I have to go second sine of that crazy number. And when I do that, that tells me that angle C is 33 degrees. So now I could do the, well, no, I guess I can't. So now I have to just recognize that all three of those angles are going to add up to 180. So 180 minus 81 minus 33 leaves me 66 degrees for angle B. So same thing on this next one. I'm going to use 48 degrees and 32 because those are across from each other. And then I'm going to start out by finding angle P because I know the side across from it. So sine of P divided by 26. So I cross multiply. So 26 sine of 48 divided by 32. So that means the sine of P equals 0.603805171. So if I want to find out what angle P is, I have to go second sine of that. And that gives me about 37 degrees. So that's 37 degrees. To find the next one, same thing as we did in the last problem. I'm going to subtract 37 and 48 from 180 degrees. And that leaves me 95 degrees for angle Q. Okay, and then it looks like it's the exact same thing here again for the last one. So hopefully you guys are getting that, or for the next one. So hopefully you're getting the hang of this. Sine of 78 divided by the length of the side opposite it equals, I'm going to start with K because that is the angle that's across from the side that I know. So once again, to find out what the sine of that angle is, I have to cross multiply and divide. So 106 times the sine of 78 and then divided by 105 gives me about 0.987463292. So to find my angle, I have to go second sine of that answer. And that gives me, if I round the nearest degree, 81 degrees. And so 180 minus 81 minus the 78 that I knew already leaves me 21 degrees for angle M. Okay? All right, I was hoping to finish this, but I don't think that we're going to be able to. Oh, yeah, one more problem. Let's finish this side, please. All right, so it says a large helium balloon is tethered to the ground by two taut lines. Ooh, I don't know if we're going to be able to make this or not. It's tricky. So I've got a helium balloon. Let's make a helium balloon. So there it is. And it's tied to the ground by two lines. And there's no slack in either one of those lines is what they mean by taut. And they both, of course, make angles with the ground. This line is 100 feet long and makes an 80-degree angle with the ground. This one makes a 40-degree angle, and we don't know how long it is. So we want to find two things. We want to figure out how long is that line, and then how far apart are those two things. And so real quick, I don't know if I have time to finish this or not. I'm going to make a right triangle, of course, out of this. And if I do that, then I can take this side over here and figure out what this missing height is. So since I know this angle is 80 degrees, h is opposite of that, 100 is the hypotenuse. So that means the sine of 80 degrees is equal to the opposite side over the hypotenuse. And so that means the height is going to be 100 times the sine of 80 degrees, which is 100 sine 80. That comes out to be 98.5 feet. So this distance right here is 98.5. Okay. So now I can use that to figure out this missing piece here, which is a tricky one, because that is also the opposite side, and we're trying to find the hypotenuse. So I'm going to use sine again. So this time the sine of 40 equals the opposite side, or 98.5-ish divided by x. So what I'm trying to find is on the bottom. This time I need to divide, so x is going to be 98.5 divided by the sine of 40, which comes out to be 153.2. So that is one of our answers there. Then to figure out what y is, we're going to have to do two separate problems, so I'll leave that up to you. I will use the cosine in this little angle, or this little triangle right here, to find this part. I don't know, call it W. Use the cosine, or you could use the Pythagorean Theorem, I guess, to find this piece right here in that triangle. And then if you add those together, those will give you the value for y. Okay? All right, so if you had a chance to finish those up, hang on to them, I guess, because we still need to do the backside, and I will go over those questions with you when I promise I am here for the first time in 3 weeks tomorrow.